We're going to go ahead and take notes over section 1.1 exponent rules. And so our objective for today is to understand exponent rules and simplify exponential expressions. So first of all, let's think about what an exponent is and make sure that we are on the same page when we use different terms to describe exponents. So I think of exponents as b to the e. The b, which is the large number, is the base. So whenever I mention the base, I'm talking about the large number. And then the e, the small number, is the exponent. So for example, if I were to have 3 squared, 3 would be my base, 2 would be my exponent. So our first thing that we're going to look at is 0 as an exponent. But to figure out what the rule is for this specific property, let's look at patterns and see if we can figure it out for ourselves. So we're going to start over here in this column where 2 is our base. So I have 2 to the 4th, which if I multiply that out, 2 times 2 times 2 times 2, that would equal 16. Next I have 2 to the 3rd, which is 8. 2 squared is 4. 2 to the 1st is just 2. And now to figure out what 2 to the 0 power is, I'm going to look at my pattern of what's happening here. So I'm asking myself, how do I get from 16 to 8, and then from 8 to 4, and then from 4 to 2? Well, I'm dividing 2 every single time. Just like when I go from 2 to the 4th to 2 to the 3rd, and then 2 to the 3rd to 2 squared, and then 2 squared to 2 to the 1st, I'm just taking away a 2 every single time. So to get from 2 to the 1st to 2 to the 0 power, I need to divide by 2. So 2 divided by 2 is 1. Let's go ahead and look at when we have our base of 3. So 3 to the 4th power, once again, if I multiply that out, I get 81. And then 3 to the 3rd power is 27. 3 squared is 9. 3 to the 1st is 3. So once again, I'm going to look at this and ask myself, how do I get from here to here? Each time, well, I'm dividing by 3. So to get from 3 to the 1st to 3 to the 0 power, once again, I'm going to divide by 3. 3 divided by 3 is 1. So let's go ahead and take a guess of what 4 to the 0 power is going to be. If 2 to the 0 power is 1, 3 to the 0 power is 1, we can guess that 4 to the 0 power is also going to be 1. Well, let's go ahead and try it out just to make sure. I have 4 to the 4th power, which if I multiply it out, you end up getting 256. 4 to the 3rd is 64. 4 squared is 16. 4 to the 1st is 4. Now you might not see it right off the top of your head, but once again, to get from one exponent to the next, we are dividing by 4. So just like in all the others, to get from 4 to the 1st to 4 to the 0, we're going to divide by 4 to get 4 to the 0 power equaling 1. So our 0 as an exponent property, so this is what we're going to write out in words, is going to be anything except 0 0 is our little exception here. So anything else except 0 to the power of 0 equals 1. So for each of these properties, we're going to write out a rule. And for this rule, it's going to be kind of like an example of it, but it cannot be just an example with numbers. Because if I were to say 3 to the 0 equals 1, all that's saying is when I have 3 to the 0 power, I get 1. That doesn't tell me anything about what if I had 4 to the 0 power. So we need to say something that's a little bit more vague that any number could apply to. So we're going to go ahead and use variables for when we can plug in any number. So I had 3 to the 0 equals 1, and then 4 to the 0 equals 1. The only thing that's changing here is my base. So I'm going to write my base as a variable. I'm going to say a. It's to the 0 power, and it's always going to equal 1. And then, of course, that is only when a does not equal 0. But my rule, a to the 0 power equals 1. So that means that I can plug in any number except 0 for a, and this is always going to be a true statement. All right, let's go ahead and go on to the next one. We have the negative exponent property. So we're going to use this pattern that we were just working with, and we're going to continue on. So to get from a power of 4 to a power of 3, and then a power of 3 to a power of 2, and then a power of 2 to a power of 1, and then a power of 1 to a power of 0, over on the left column, when our base was 2, all we did was divide by 2 every single time. So to get from a power of 0 to a power of negative 1, once again, we're going to divide by 2. So 2 to the negative first power, all I'm doing is I'm dividing by 2. So I'm taking 1 divided by 2. And then to get from there to the next one, I'm going to divide by 2 again. So I'm going to take 1/2 divided by 2. Well, if I think about division with fractions, dividing by a fraction by a number, I'm going to multiply by the inverse. So I get 1/4. And then for 2 to the negative third, once again, I'm going to divide by 2 or multiply by the inverse to get 1/8. I'm going to go ahead and make this a little bit smaller so that I can fit one more thing in here. Now notice that 1/2 is the same as 1/2 to the first, and 1/4 is the same as 1/2 squared, and then 1/8 is the same as 1/2 to the third. So if we look at patterns here, we have 2 to the first, and then 2 to the negative first is the same as 1/2 to the first. And then 2 to the negative second is the same as 1/2 to the second. And then 2 to the third is the same as 1/2 to the third. So let's look at threes. If we're seeing a pattern, let's try it, make sure it works with another one. So if I have 3 to the negative first, all I'm going to do is I'm going to take this 1 and I'm going to divide by 3. And then to get from 3 to the negative second, once again I'm going to divide by 3 or multiply by the inverse to get 1/9. And then 3 to the negative third, once again I'm dividing by 3 or multiplying by the inverse, and I get 1/27. Once again, I'm going to make these a little smaller so I can fit the last part in here. 1 over 9 is the same as 1 over 3 squared. 1 over 27 is the same as 1 over 3 to the third. Once again, I'm looking at these patterns and I'm noticing that to get from 3 to the negative first to 1 over 3, and then 3 to the negative second to 1 over 3 squared, and 3 to the negative third to 1 over 3 to the third. I'm taking the inverse of it, and then I'm making it positive. So my negative exponent property states a negative exponent means the inverse of. So in some not so mathematical terms, you are going to flip the fraction and then make the exponent positive. However, we are great mathematicians, so we can say when you have a negative exponent, you take the inverse of that base, and then your exponent becomes positive. Now, to write this as a rule, I'm going to write it out two different ways. I'm going to say when I have any base to any negative exponent, I'm going to take the inverse of it, so it's going to create a fraction. I have that same base, but my exponent becomes positive. My other option is what if I start out with a fraction? So what if I have 1 over any base to a negative exponent? Well, in those not so mathematical terms, I flip the fraction, which means that a to the negative b moves up to my numerator, and then that negative exponent becomes positive. So this is my rule for the negative exponent. I'm moving on to product of powers. Let's go ahead and look at some different products here and see if we can figure out what this property is going to be, what my rule is going to be. I'm going to zoom in here. So I have 2 times 2, which I know is 4. 2 times 2 squared, well, that's the same as 2 times 4, which is 8. 2 squared times 2 squared is 4 times 4, which is 16. And then 2 to the 0 power times 2 to the third. Well, I know 2 to the 0 is 1, and 2 to the third is 8, so this equals 8. Now, if I were to write these numbers out with 2 as my base, 4 would be 2 squared, 8 would be 2 to the third, 16 would be 2 to the fourth, and 8 would be 2 to the third. If I study my original statement and then my final statement for each of these, I can notice that I take each of the exponents and I add them together to get my new exponent. So once again, I'm taking my original exponents and I'm adding them together to get my new exponent. Another way to see this is, let me switch colors. So when I have 2 times 2, there are 2 2's that I'm multiplying together. When I have 2 times 2 squared, that's the same as 2 times 2 times 2. If I were to write that out, I have 3 2's that I'm multiplying together. 2 squared times 2 squared, if I were to write that out, I have 4 squares, 4 2's that I'm multiplying together. And then 2 to the 0 times 2 to the third, well, I have 0 2's times 3 2's, so I end up with 3 2's that I'm multiplying together. So let's go ahead and figure out what the 3's are going to equal and see if it matches with this property. So I'm going to start with 3 times 3. Well, I know that's 9, which is 3 squared. I have 2 3's that I'm multiplying together. 3 times 3 squared, well, that's 3 times 9, which is 27. If I were to write that with my base of 3, I get 3 to the third. 1 plus 2 equals 3, so that works out. 3 squared times 3 squared is the same as 9 times 9, which is 81. If I were to write that with a base of 3, that would be 3 to the fourth. 2 times 2, or 2 plus 2 is 4, so that works. And then my last one, 1 times 27 is just 27. Writing that with a base of 3 is 3 to the third. 0 plus 3 is 3. So it works out for both of those different bases. I'm going to go ahead and move over and we can write out this property. So this property is going to state when multiplying numbers with the same base. This is very important that they have the same base. If they have different bases, so say I have 2 to the second times 3 to the second, I cannot combine those at all. Right? Those are going to stay separate. I can only combine them if they have the same base. You're going to add the exponents. So when multiplying numbers with the same base, add the exponents. So this rule that I'm going to write out, once again, I need to use variables to show that I can put any number in for this base and exponent. I'm going to have a to the b times a to the c. Notice that I have the same base for both of those. That's going to equal a to the b plus c. So the base stays the same and I just add together my exponents. All right, I'm going to move on to the last property on this side of our note guide. We have quotient of powers. So this one's going to be very similar to the product of powers, except this time we're dividing instead of multiplying. And so you can take a guess at what we're going to do instead of adding. Well, let's go ahead and try this out. I have 3 squared divided by 3. That's the same as 9 divided by 3, which equals 3. If I were to write that with a base of 3, that would be 3 to the first. Now, when I do my product rule, so when I'm multiplying, I add my exponents. So now when I'm dividing, I'm going to subtract my exponents. So if I look at this, if I take 2 minus 1, I end up getting 1. Well, let's keep trying this out for a few more. 3 to the fifth divided by 3 squared. This is a little trickier. I don't know 3 to the fifth off the top of my head. And I want to show you this in a different way anyways. So 3 to the fifth is 3 times 3 times 3 times 3 times 3. And then I'm going to divide that by 3 squared. Well, notice that I can cancel those out. And I'm just left with 3 to the third, which would be 27. If I were to subtract my exponents, I'd get 5 minus 2, which is 3. So this still works out whether or not I am finding the value of it, or if I am writing it in expanded form. Let's figure out if it works when I have a larger exponent in my denominator. So 3 over 3 squared is going to be 3 over 9, which is 1/3. That's the same as 1 over 3 to the first. If I were to subtract them, I would do 1 minus 2, which is -1. So I would have 3 to the negative first. Is 3 to the negative first equal to 3 to the first? Yes, it is. We just learned that with our negative exponent rule earlier in these notes. If I were to write this out in that expanded form, I would get 3 over 3 times 3. Those would cancel out, and I would be left with 1 over 3. And then my last one, 3 over 3. 3 divided by 3 is 1. If I were to subtract my exponents, I would do 1 minus 1, which is 0. So I'd have 3 to the 0 equals 1. Is that true? Yes, it is. Once again, I learned that from my earlier in these notes when we learned the 0 exponent rule. So coming over here to my quotient of powers property, it's going to be very similar to my product of powers property, but now it's going to say when dividing numbers, once again, they have to have the same base. So when dividing numbers with the same base, I'm going to subtract the exponents. When dividing numbers with the same base, subtract the exponents. My rule is going to be similar, except this time I'm dividing. I have a to the b over a to the c. That's going to equal a to the b minus c. Now, one thing I want to point out, looking back over at this problem here, when I did my 1 minus 2, I got a negative number. That base with that exponent, whether it becomes positive or negative, would be in a numerator of a fraction. So if I were to write this as a fraction, it would have been 3 to the negative first over 1. And that information will become a lot more important as we once we finish up all these properties and do some examples. And we have some pretty intense examples on the back of this note guide. So let's go ahead and flip this note guide over and move on to our next property, which is power of a product. So with power of a product, now we have numbers inside of parentheses, and then we're going to take them to a power. And so we're multiplying inside, which is where product comes from, and then we're taking it to a power. So let's see what is happening here. If I have 3 times 2 to the third, 3 times 2 is 6, and then 6 to the third is 216. Now, one thing I want to point out is, let's just see what would have happened if I had distributed that 3 to both numbers inside of the parentheses before multiplying. Because as you could tell, I didn't know what 6 to the third was off the top of my head. I went to the calculator just for time's sake, but I also could have done the multiplication out over here to the side. So let's see if this makes it simpler multiplying that through. So if I were to have 3 to the third times 2 to the third, that would be 27 times 8. Now I can do that multiplication to figure out that it is 216. So I got the same answer both of those ways. Let's see if that pattern continues. So this next one I have 3 times 2 quantity squared. So I'm once again going to multiply that 3 times 2 to get 6. 6 squared is 36. If I were to distribute that power of 2, I would get 3 squared times 2 squared, which is 9 times 4, which is 36. So it still works. Next one, I have 6 to the first, which of course is just 6. And then 3 to the first times 2 to the first is 6. So it is still working even with a power of 1. Let's see if it works with a power of 0, because that kind of makes things a little different. I'm going to multiply inside my parentheses first. So 3 times 2 is 6. I'm going to take that to a power of 0. And I know anything to a power of 0 equals 1. Let me try by distributing that 0. So I'm going to do 3 to the 0 times 2 to the 0. Well, 3 to the 0 is 1, 2 to the 0 is 1, and 1 times 1 equals 1. So it is still working. All right, now that we're becoming a little bit more familiar with these negative exponents, let's try this next one and see if this property still works with a negative exponent. We see that it works with the positive exponents, it works with 0, and now it's time for negative. So once again, I'm going to take 6 to the negative first power. I'm going to take the inverse of it and then make that exponent positive. So I would have 6 to the positive first, but I don't need that exponent of 1. And then let's try it by distributing. So I'm going to take 3 to the negative first times 2 to the negative first. 3 to the negative first is 1/3. 2 to the negative first is 1/2. And I know when I multiply fractions, I'm going to multiply straight across, and I get 1/6. So it still works with negative exponents. So my power of a product property states when multiplying numbers, then taking that product to a power, or to an exponent, you can distribute the exponent to each part of the product. So each item in the parentheses. This rule is going to look like this. I can take any number times any number to any product, and that's going to equal that first number to a power. It's going to equal the first number to that power times the second number to that power. All right, moving on to product of a quotient. Just like the properties from the front page of this note guide, the power of a product and power of a quotient properties are going to be pretty similar. So looking at this one, I have 4 over 2 to the third. Just like with power of a product, let's try this out by working inside of the exponents, or inside of the parentheses first, and then let's try by distributing that exponent. So 4 over 2 to the third. I'm going to do 4 over 2, which is 2, and then take that to the third, which is 8. If I were to distribute, I would get 4 to the third over 2 to the third, which would be 64 over 8, which equals 8. The next one, let's do 4 over 2 squared. First, I'm going to work inside the parentheses. 4 over 2 is 2. So I have 2 squared, which is 4. Now if I were to distribute that, I would get 4 squared over 2 squared, which is 16 over 4, and that equals 4. So that checks out still. Now 4 over 2 to the first power. So 4 over 2 is 2, to the first is just 2. Now 4 to the first over 2 to the first, well, that's just 4 over 2, which is 2. So this is still working out. Let's try it with the 0, and then let's try it with that negative exponent to make sure it's still working when we don't have that positive exponent. So 4 over 2 to the 0 power, 4 over 2 is 2, 2 to the 0 is 1, and now distributing, I get 4 to the 0 over 2 to the 0, which is 1 over 1, and that equals 1. It is still working. And then my last one. So this one might be a little different since we are going to be working with inverses. So I have 4 over 2, which is 2. And I'm going to take that to the negative first. So I'm going to take the inverse of it, and then that exponent becomes positive, so I get 1/2. Now if I were to distribute first, I'd get 4 to the negative first over 2 to the negative first. Well, what's happening here, this is a fraction, which is the same as division. So I'm going to write 4 to the negative first divided by 2 to the negative first. 4 to the negative first is 1/4. 2 to the negative first is 1/2. And then when I'm dividing fractions, I'm actually multiplying by the inverse. So I get 2 over 4, which simplifies to 1 over 2. So even though that was a lot more steps, it still works out for negative exponents. So the power of a quotient property is going to say, when dividing numbers, then taking the quotient to a power, distribute the exponent to each part of the quotient. And this rule is going to look like A over B to the C. So any number divided by any number to any exponent equals A to the C over B to the C. All right, let's move on to our last and final property. We have power of a power. So power of a power, we're looking at problems like this, where we're taking a number, a base to an exponent, and then we're taking that whole quantity to an exponent. So 3 squared, what's really happening here is I'm taking 3 squared times 3 squared. And so that is 9 times 9, which is 81. Now, if I were to write this, the 81, as a power of 3, with 3 as my base, I would have 3 to the 4th. Now, there's a couple different ways that I could have looked at this problem. Instead of seeing that as 3 squared times 3 squared, I could have looked at that as 9 squared. So I could have worked inside of my parentheses first and then squared it. I can also expand it, and I can say, well, 3 squared is 3 times 3. And I'm squaring that, so I'm multiplying 3 times 3 times 3 times 3, which is the same as 3 to the 4th. Right now I'm going to look at 3 squared to the 3rd. And so I'm going to look at this. I don't really care as much about like what this actual value is. I want to see what happens to my exponents. So I have a couple different options. I can write it out in expanded form, or I can multiply it out and then convert it back. But let me go ahead and write this out in expanded form because I feel like that would be simpler. So 3 squared to the 3rd is the same as 3 squared times 3 squared times 3 squared. I'm taking this parenthesis and I'm multiplying it by itself 3 times. So I'm going to write that as 3 times 3 times 3 times 3 times 3 times 3. So I get 3 to the power of 6. So what is happening here? What is happening with my exponents? Well, if you look at the exponents in the original expression and then the exponent in the final expression, you'll notice that you're multiplying those exponents to get your final one. So let's see if that continues to happen with these other problems. So I have 2 squared to the negative first. Well, to the negative first, I'm just doing 1 over 2 squared, which is 1 over 4. If I were to multiply them, I would have done 2 to the negative second, because 2 times negative 1 is negative 2, which is 1 over 2 squared, and that's 1 over 4. Now, so that works out for that negative 1. Let me try it for negative 2. So I have 2 squared to the negative second. So that is like 4 to the negative second, which is 1 over 4 squared, 1 over 16. Or if I'm going to write that with a base of 2, that would be 1 over 2 to the 4th. 1 over 2 to the 4th is the same as 2 to the negative 4th. So it still works out. Let's make sure it works for 0, because 0 is kind of that different one. So if I have 2 squared to the 0 power, well, I know that anything to the 0 power is 1. But what if I multiply them? So I would have 2 to the 2 times 0 power, which is just 0. So that does still equal 1. So coming over here to write out my power of a power property, you're going to say, when taking a base and exponent to a power, multiply the exponents. So my rule looks like this. I have a base, I'm taking it to any exponent, and then that's inside parentheses, and I'm taking that whole thing to any exponent. Well, I'm going to take that base to those two exponents multiplied together. So a to the b, quantity to the c, equals a to the b times c. All right, we just learned 7 different properties, and we wrote out 7 different rules for all these different exponent rules. So now let's see if we can put them all together and simplify all of these expressions. So 1 through 8 are the types of problems you're going to be seeing on your homework. When you do these, you always want to write your final answer as a single expression. So that means don't have a bunch of things being multiplied like this. It should all be one single expression. And they should have a positive exponent. So if you have an answer that has a negative exponent, you need to go one step further and write the inverse of it. So this first one, 2z to the 4th. Well, I'm going to use my power of a product rule, and I'm going to distribute that 4. So this would be 2 to the 4th times z to the 4th. And then I'm going to simplify that. I know 2 to the 4th is 16, so my answer is 16z to the 4th. Number 2, I have 4g to the 5th to the negative 2nd power. So once again, I'm going to distribute that negative 2. So I get 4 to the negative 2 g. Now I'm going to use my power of a power rule, and I'm going to do 5 times negative 2, which is negative 10. All right, now I need to simplify this, and I need to get rid of these negative exponents. So to do that, I know 4 to the negative 2nd. Well, first let me think. What's 4 squared? That would be 16. And then I want to write it as, I need to take the inverse of 16, which would be 1 over 16. And then I have g to the negative 10th, and I want to take the inverse of that, which is 1 over g to the 10th. Now this says write as a single expression, so I need to combine these and write this as 1 over 16 g to the 10th. All right, I'm going to move on to number 3. I have 3t to the 0 power to the 4th power. So once again, I'm distributing that 4, and I get 3 to the 4th times t to the 0, because 0 times 4 is 0. Well, 3 to the 4th is 81. T to the 0 is 1. And so my final answer is just 81. Moving on to number 4. This is getting a little bit more complicated. So I'm going to take this one part at a time. First, I'm going to do this part, the first part of the product, and then I'm going to do the second part of the product. And then I will go another step and I'll combine these. So first, d to the 3rd to the 5th. I have my power of a power rule. So I'm going to take d to the 15th. And then the second part, I have d to the 3rd squared. So once again, I'm using that power of a power rule to get d to the 6th. And now I need to use my product rule that states when I am multiplying numbers with the same base, I need to add the exponents. So I keep my base and I add the exponents to get d to the 21st power. Number 5 is similar, so let's go ahead and do this one. Do this one on your own. All that we're doing is we're adding a negative exponent in here. And so pause the video, work this problem out, and then compare and make sure that we agree with our answer. So this one I have x to the 3rd to the negative 1st. So I get x to the negative 3rd. And then x squared to the 5th, that is x to the 10th. And then I need to get rid of that negative exponent, and I do that by imagining this as a fraction and moving that x to the negative third down. So I get x to the 10th over x to the third. Well, I still have two x's in here, so I need to simplify this further. So I'm going to use my quotient rule that states when I'm dividing numbers with the same base, I'm going to subtract the exponents. 10 minus 3 is 7, so I have x to the 7th. Now there were a couple different steps that you could have taken in this problem. When you were at this point, instead of moving that x to the negative third down by taking the inverse of it, you could have used the product rule and done negative 3 plus 10 to still get x to the 7th. You also could have started off in a different way. Instead of using the power rule right here, you could have went ahead and used that negative exponent rule. So you could have gone ahead and written this as 1 over x to the third times x to the 10th, and then you would have gotten to that point. So those are a couple different options. There's not one single correct way to go about simplifying these problems, and this is a very good example of that. No matter which way you go, you should still get the same final answer. All right, number 6. This one is getting more complicated, but once again, just take it one step at a time. So first, let's do this first part, and then we'll do the second part, and then we can combine them. So this first part, I'm going to distribute that power of 2 to each part of the parentheses. So I have 5 squared, which is 25, p to the 6th because I'm multiplying, q to the 4th, and that's going to be multiplied by this second part, once again distributing that 3. 2 to the 3rd is 8. Then I have p to the 12th and q to the 3rd. And now I'm going to combine these. So I'm going to combine my numbers, and then I'm going to combine my different variables. So 25 times 8 is 200, and then p to the 6th times p to the 12th. I'm multiplying numbers with the same base, so I am adding the exponents. And then my q's, I have q to the 4th times q to the 3rd. I'm multiplying numbers with the same base, so I am adding those exponents. This is going to be my final answer because I cannot combine any of the rest of it. The numbers stay separate, and then I cannot combine different bases. Let's go on to number 7. All right, this is where you really need to be careful with what you're doing, and problems that start getting more intense like this are the type of problems that you're going to have many different ways to do these. So what I like to do when I have problems like this is I like to work inside of the parentheses first to simplify. Now when I'm working inside of the parentheses, I'm going to work with my numerator first and then my denominator. And then once I get all of that simplified, then I'll take it to the power of 2. So first I'm looking at my numerator, which is 6ts squared to the negative first. Well, that actually ends up moving down to my denominator. So I'm going to move my 6ts squared, and then it becomes the positive power of 1, so I can leave it like that. And then my denominator is 3tm cubed, m to the 6th, to the 0 power. Well, that whole thing is to the 0 power, so that whole thing becomes 1. And so that's all that I have inside of my parentheses. And then everything from my numerator moved down to my denominator. So I need to just make my numerator 1. And then this is to the 2nd power. So I'm going to simplify that, and then I will distribute that squared. So I'm going to write this as 1 over 6ts squared to the 2nd power. And then I need to distribute that exponent to every single part of this parenthesis. So 1 squared is still 1. In my denominator, I now have 6 squared, t squared, and then s squared squared. So that looks like this. I'm going to use that power of a power rule to get s to the 4th. And this is my final answer. I cannot simplify it any further. It's written as one expression, and I have no negative exponents. Go ahead and see if you can do this next one on your own, and then I will also work it out. I will show you a couple different ways to go about this type of problem, and then you will be prepared to do all of your homework on your own. So on this one, just like on the problem before this, I'm going to work inside of the parentheses first, and then inside of those parentheses, I'm going to be doing my numerator, and then I will work with my denominator. So my numerator, I have 3s to the negative 2nd, t to the 7th, to the 3rd. So I'm going to distribute that exponent of 3 to everything inside of those parentheses. So I have 3 to the 3rd, which is 27, s to the negative 2 times 3, which is negative 6, and then t to the 7 times 3, which is 21. Now my denominator, everything inside that parentheses is to the power of 1. So it just becomes 6s to the 3rd, t to the negative 5th. And then that whole fraction is to the negative 4th power. Now next I'm going to simplify that fraction. Now that I have no parentheses, I can move my negative exponents around. I can make this all one quantity, and then I'll take it to that negative 4th power. So I have s to the negative 6th and s to the 3rd. I'm going to work with my variables first, and then I'll tack on those numbers at the end. That's just kind of how my brain likes to think of it. So I have two different ways to think about this part right here. I can either think of this using the quotient rule, and in that case I would get, I would do negative 6 minus 3, which is the same as adding a negative. So I'd get negative 9 as my exponent. So I have s to the negative 9th. And then same with t to the 21st over t to the negative 5th. I would have 21 minus 5, which is the same as, sorry, I wrote that wrong. I would have 21 minus negative 5. I'm going to add that inverse to get 26. So I have t to the 26th. And then 27 over 6, I cannot divide that, but I can simplify it. I can divide a 3 out of both of those numbers to get 9 over 2. And I'm going to simplify this one more step before I take it to the negative 4. I can take the inverse of that s to the negative 9th. So I can have 9t to the 26th over 2s to the 9th, and then take that to the negative 4th. So now I'm going to go ahead and do that negative 4 power. And so I have 9 to the negative fourth t to the negative 26 times 4. I don't know that off the top of my head, so I'm going to have to do this multiplication. T to the negative 104 over 2s to the negative 36 to the negative fourth s to the negative 36. And now I need to simplify this further. So now I have, my numbers need to switch around. And then my variables also need to switch around. Once that happens, my exponents all become positive. So what happened here is I had 9 to the negative fourth. Well, that's a negative exponent, so it's going to move down. And then t to the negative 104, that's a negative exponent, so it's going to move down. And then 2 to the negative fourth is going to move up because it's a negative exponent, and same with s to the negative 36. And now my last and final step is I need to simplify my numbers. So I have 2 to the fourth, which is 16 s to the 36 over 9 to the fourth. I'm just going to multiply this out real fast for time's sake. And I get 6,561 t to the 104. So those numbers got pretty large. That was a lot of work for that one. Now another option would have been distributing that negative 4 first and then going through and simplifying it from there. So I'm going to show you what that looks like so that you can decide what you prefer when you're doing these problems on your own. All right. So first I'm going to distribute that negative 4. So in my numerator, that negative 4 is just going to go to those powers there. So I'm going to get 3s to the negative second t to the 7th to the negative 12th over 6s to the 3rd t to the negative 5th to the negative 4th. And now from here, I can do all of my simplifying. So I'm going to go ahead and distribute those exponents to each part of those parentheses. So I get 3 to the negative 12th, s to the 24th, t to the negative 84th over 6 to the negative 4th, s to the negative 12th, and t to the 20th. Now simplifying this, I'm going to simplify my variables first. So I have s to the 24th over s to the negative 12th. So I have 24 minus negative 12. I'm going to add that inverse. 24 plus 12 is 36. And then t, I have negative 84 minus 20. Adding that inverse, I get negative 104. And then 6 to the 4th and 3 to the negative 12th. 6 to the 4th is going to end up in my numerator. 3 to the negative 12th is going to end up in my denominator. And for this next step, now that I have them in the right spots, I will multiply those out. All right, this next step, I'm going to multiply those out like I said. So I'm going to do 6 to the 4th, which is 1,296. Then I have s to the 36, 3 to the 12th, 531,441. And then this t to the negative 104, I can go ahead and move down to make that a positive 104. And now all I have left to do is to simplify 1,296 over 531,441. '81 goes into both of those numbers. And so if I take 1,296 divided by 81, I get 16. Then I have s to the 36. And then if I take 531,441 divided by 81, I get 6,561, t to the 104th. So notice, either way that I do this problem, I end up getting that same answer. It just depends on which way you prefer. Now, I know that was a doozy of a problem, and I just went through multiple steps for it. That's about as complicated as it's going to get, but I wanted you to be exposed to that before you got to your homework. So go ahead and start working on that homework now if you have not already. And then if you have any other questions, you can come talk to me outside of class. The answer key for the homework is up on Canvas, so once you get that homework done, you can check it.